Okay, kiddos, today we're going to do some operations with radicals. We're going to be adding like radical terms, and we're going to be multiplying radical terms. Anyway, it says combine like terms right here. It's kind of like this. When you have 3x squared plus 2x minus 7x squared. I can't add all these three terms, but I can add the x squared terms because they're what we call like variable terms. They have the same variable to the same power. And 3 minus 7 is negative 4. X squared plus 2x. But I can't add the 2x to the negative 4x because they're the same variable but not the same power. It's kind of the same thing for these square roots or these radicals. They have to have the same square root, same radical, with the same number underneath it. So all of these have a square root of 3. So we just add the numbers in front. So I got 2 plus 5 minus, if there's nothing there, it's a 1. 2 plus 5 is 7 square roots of 3. Minus, that's 1 square root of 3. 7 minus 1 is 6. So that's 6 square roots of 3. Okay, so let's go over this one. Same kind of thing. Add the like radical terms. Here's a square root of 5, and here's a square root of 5. That's 3 minus 4. Well, that's negative 1, so that'd be negative 1, or just negative the square root of 5. Here we have a square root of 2, and here we have a square root of 2. Now remember, that's 1 square root of 2. So 2 plus 1 is 3, so it's plus 3 square roots of 2. There we go. And we're done. This one, it says to simplify first. Well, none of these are the same. I have 12, 27, and 48 underneath my square roots. So what we need to do is get them in simplified radical form, and then we can maybe combine them if they have the same radicals. So I'm going to break down 12 first, and 12 is 4 times 3. 3 is prime, and then 2 times 2. Now, 4 isn't prime, so I'm not worried about that. So this 2 square roots of 12 is actually 2 square roots of 2 times 2 times 3. And I can take out a 2 there. Now there's a 2 outside already. Now it's 2 times 2, which is a square root of 4. Square root of 4 is 2, so it's not going to be 2 more 2's out there. That's just a root of 2 on the outside. And then this 3 stays underneath the square root. So this is 4 square roots of 3. The 27 is 3 times 9. 3 is prime. And then 3 times 3. So it's basically 3 3's. So it's minus 3 square roots of 3 3's. And you know what we can take out of that? We can take out a pair of 3's. That's like the square root of 9. Now there's a negative 3 out there already. I'm going to multiply it by a root. It becomes a root of 3. And this 3 stays underneath the square root. There's a lot of 3's there. So basically, negative 3 times 3, that's negative 9. So minus 9 square roots of 3. And then the 48. We'll break down that 48. That's 4 times 12. 4 is 2 times 2. 12 is 4 times 3. 3 is prime. And then another 2 2's. Now remember, 4 isn't prime, so I'm not going to put that in there. So plus 2 square roots of, looks like 1, 2, 3, 4 2's and a 3. What can we take out of there? Well, 1 pair of 2's. Now there's a 2 out there already, this 2. So a pair of 2's becomes a root of 2 on the outside. Another pair of 2's becomes another root of 2 on the outside. Then you got that 3 left over. Well, 2 times 2 times 2 is not 6. It's 2 times 2 is 4. 4 times 2 is 8. So this is plus 8 square roots of 3. Now, in the beginning, none of them were the same. Not like radical terms. But when you simplify them, they're basically all square roots of 3. And I'll do the positive first. 4 plus 8 is 12, so that's 12 square roots of 3 minus 9 square roots of 3. 12 minus 9 is 3, so my last answer, final answer, is 3 square roots of 3. All of this simplifies down to that, 3 square roots of 3. Okay. We're going to do the same thing here. We'll start out with this 8. Maybe I can simplify that. That's 4 times 2, and 4 is 2 times 2, so 3 2s. So that's 3 square roots of 2 times 2 times 2. And we can pull out a pair of 2's, which is a root of 2, because the square root of 2 times 2 is just 2. That's 3 times 2. This 2 stays inside the square root, so this is just going to end up being 6 square roots of 2. The 32 here, that's 4 times 8. 4 is 2 times 2. Remember, we don't put the 4 in there. 8 is 2 times 4. We got that 2 right there, and 2 times 2. So basically, it's 1, 2, 3, 4, 5 2's. So it's plus 5 square roots of 1, 2, 3, 4, 5 2's. And what can we take out of there? Well, 1 pair of 2's, so that's plus 5 times, there's a 2. Another pair of 2's is a root of 2, and this 2 stays in there. 5 times 2 is 10, 10 times 2 is 20. So this is plus 20 square roots of 2. 18. Okay, that's 9 times 2. 2 is prime. And then 3 times 3 is 9. So minus 4 square roots of, what do we got there? A 2 and 2 3's. So there's a pair of 3's. So it's negative 4 times that root of 3. And this 2 stays in there. So minus, well, negative 4 times 3 is negative 12 square roots of 2. So 6 and 20 is 26 square roots of 2 minus 12 square roots of 2. I would say 26 minus 12 is 14 square roots of 2. So little simplifying radicals, we're practicing that again, and what else are we doing? And adding, combining like radical terms. Here it says to expand. Basically, we're going to multiply it. And just to remind you a little bit, when you're multiplying square roots, they don't have to be like radical terms. I can say like 5 square roots of 2 times negative 3 square roots of, I don't know, we'll say 6, okay? You multiply the numbers on the outside. The coefficients, 5 times negative 3 is negative 15. And then multiply the numbers underneath the square roots. 2 times 6 is 12. And that would be your answer, but 12 can be simplified. 2 times 6, and 6 is 2 times 3. So I can say this is negative 15 square roots of, what do we got? 2 times 2 times 3. So I'll take out a pair of 2's. Negative 15 times 2 is negative 30 square roots of 3. So there's a little work when you're multiplying. Okay? But now we're multiplying 2 terms times another 2 terms. So binomial times a binomial. Now you guys probably are used to the box method. So we'll try the box method, and then I'll show you just distributive property twice. That's what I usually do. And you use whatever method you want. So box method. Let's do it right here. This is your first, this is your second. So that's 3 square roots of 5. Oh boy, I gotta get it going here. 3 square roots of 5 minus 2 square roots of 3. And then I'll put the 2 and the square root of 3, and it's plus the square root of 3 right here. So multiplying this, first of all, this row by this column, 3 square roots of 5 times 2. Well, the 2 times the 3 is 6, and there's no other radical, so it's just the square root of 5. And then that 2 times this negative 2 square roots of 3, that's negative 4 square roots of 3. Now we're multiplying this bottom row times the first column. And it's basically 1 square root of 3 times 3 square roots of 5. 1 times 3 is 3. And 3 times 5 is 15. So it's the square root of 15. And then I'll just do it down here. 1 square root of 3 times negative 2 square roots of 3. Well, 1 times negative 2 is negative 2. And 3 times 3 is 9, so that's the square root of 9. Well, I know the square root of 9 is 3, but let's list this out. 6 square roots of 5 minus 4 square roots of 3 plus 3 square roots of 15 and then minus 2 square roots of 9. Now, the square root of 5 is just square root of 5, so that's 6 square roots of 5. 3, I can't break that down anymore. That's 4 square roots of 3. 15 is 3 times 5. Well, I don't have anything in common there that I can take out, so it stays 3 square roots of 15. But this is negative 2. Square root of 9 is 3, so that's negative 2 times 3, or negative 6. Now, if you look at all of these, none of them are the same. So this would be my answer right here. Every once in a while, you'd have like another square root of 5 that you would add to that first square root of 5, but in this case, we don't have that. So we're done here. That's my answer. And that's the box method. Now I'm going to show you distributive property, but distributive property twice. Like if I didn't have this, if I just had the 6, I'd distribute the 6 through here, right? But being I have 2 terms, I have to not only distribute the 6, which is negative, by the way, I have to distribute that 5 square roots of 3. So here's how I would do it. I would first multiply 5 square roots of 3 times 5 square roots of 3. Well, 5 times 5 is 25, and 3 times 3 is 9. We'll simplify that in a little bit. And then I got 5 square roots of 3 times 6. Well, there's no square root with the 6, so it's just 5 times 6 is 30. And there's the square root of 3 there, because it's 5 square roots of 3. So we're done with that one. Now I go to the negative 6, and I do the same thing, distribute it. Negative 6 times 5 is negative 30. And don't forget that square root of 3. And then negative 6 times negative 6. So I multiply 5 square roots of 3 by both those second two terms, and negative 6 by both those two terms. Negative 6 times 6 is negative 36. Now, what I want you to notice here is here I got positive 3 square roots of 30 square roots of 3 and negative 30 square roots of 3. They're going to cancel out. Here I have 25 times the square root of 9. The square root of 9 is 3. So that's actually 25 times 3, or 75. And then I got this minus 36. So we actually get rid of the square roots in this case. And that does happen once in a while. So 75 minus 36. Oh, what do we got there? 15 minus 6 is 9. 6 minus 3 is 3. So my answer is 39. Okay? Okay. So this one, it's kind of a word problem, but not really. It says, find the perimeter and area of the rectangle. Well, perimeter is the sum of all sides. So if this side is the square root of 8, the side opposite is also going to be the square root of 8. And if this side, the top, is 3 plus 6 square roots of 2, this is also 3 plus 6 square roots of 2. So I'm going to add all those up. Well, you can kind of do it in your head. 3 plus 3 right here is 6. 6 square roots of 2 plus 6 square roots of 2, that's 12 square roots of 2. And then 1 square root of 8 plus 1 square root of 8, they're like radicals. That's 2 square roots of 8. 6 is just 6. 12 square roots of 2, I can't do anything with the 2. But this 8, I can break that down. That's 4 times 2. 2 is prime. And 4 is 2 times 2, prime. So this 2 square roots of 8 is actually 2 square roots of 2 times 2 times 2. And we can pull out a root of 2. So that's 2 on the outside times this 2 that I just pulled out, and this 2 stays inside there. That's 4 square roots of 2. So we have 6 plus 12 square roots of 2 plus 4 square roots of 2. Excuse me. So what does that mean? Well, these are both square roots of 2, so I can add them up. 6 I can't add to them, but it's 6 plus 16 square roots of 2. And that's the perimeter, so that would be yards. You could label it if you wanted to. Now, for the area. Area equals length times width. So we need to take, the length looks like it's 3 plus 6 square roots of 2. Times the length, or the width right here, which is the square root of 8. So we got to do a little bit of distributive property here. First of all, the square root of 8 times 3. So that's 3 square roots of 8. And then the square root of 8 times 6 square roots of 2. Now that's 1. So 1 times 6 is 6. Numbers in front there. And then 2 times 8 is 16. So cleaning this up a little bit for the area, I would see this 8, and we broke down 8 already. That's 4 times 2, and 4 is 2 times 2. So this is actually 3 times 2 times 2 times 2. And you can take out a pair. There's 3 out there already. 3 times the root of 2 would give me 6 square roots of 2 plus 6 times, well, I tell you what, the square root of 16 is 4, right? So that's 4. So my answer is actually 6 square roots of 2 plus 24. And this is area. You don't have to label it, but it's yards squared. So there's length and area. And we are done. Now you can work on the worksheet and submit it when you get a chance. Thank you and have a good day.